in Unit 5, and we're going to start off with something called nth roots. We're basically going to learn how to rewrite from exponents to radicals, okay? And then we'll look at simplifying them. So the first thing that you should be aware of, if you have something written with a radical like this, okay? The little number, there's sometimes a little number written there, all right? That guy we call R because this is the root or the index. That is the name for this, okay? Just a little bit of math vocab here. Okay? The root or the index is that little R root. This P is the exponent, right? And that is our power. All right? And that's all for the x that's inside the radical. And this actually has a special name too. This is called the radicand. Okay? Now, if you have something that looks like this in radical form, you could change it to a fraction exponent form, okay? A rational exponent. So now we are going to take whatever is in the inside the radical, bring it over, this x, and then it's always to the power over root. Okay? This is an exponent. It's just a fraction that's an exponent. Okay? All right, so let's try rewriting. The next line says rewrite the expression using rational exponent notation. Since they wrote it with a radical, I'm going to write it as an exponent. Okay? So I'm going to bring down my radicand, which is 5. Yeah? To the power over root. What is the power for this guy? 2. And what is the root? 3. There you go. This is 5 to the 2/3 power. Okay? This is a little fraction of something exponent. All right, let's look at the next one. 32. To the, what's the power on this 32? There isn't anything written there, so what would the power be?
1.
Good. 1 over, what's the root? 5. Now, the next one. Guys, do you see a number written there for the root? It means it's 2. Why? Good. It's the square root. If there is no number written there for that root, then this is 2. Okay? Always. Because that's the square root. Now, what's inside that radical? 2 and what? X. Good. You have 2 things inside the radical, right? So you got to make sure you put that in parentheses because you want to show that both of them came out of the radical. Now, to the power of, what's the power? Is that a 6 or 5? 5 over, what's the root? 2. Okay? Now you guys try the next one. All right, this one should be x to the, what's the power on this x? 3. And what's the root? Oh, 2. Right? If there's no number written there for the root, that means it's a square root. It's a 2. Yeah?
So it's still a power regardless if it's in the parentheses.
Yeah. We put this one, the 2x in parentheses, because there was more than one thing inside the radical. All right? All right, so let's look at the next one. Guys, for the next one, I have x's and y's, right? So just write it one at a time. So the x, what is the power on that x? What's the root here? Abner, do you know what I'm asking? Yeah? Okay. The root is 3. Alright, so I'm done with the x. How about the y? What's the power on the y? Okay, what's the root? 3. Oh, you know what? Anytime that you have fractions that can be simplified, you must. Yeah. So this really turns into x to the 5/3 y what? What's 6 over 3? 2. Okay? We always simplify fractions. Alright, let's look at the next one. X. What's the power on that x? Huh? 1. No, the 12 is on the y. 1 over 2. The root is 2. Now what about the y? What's the power on the y? 12 over 2. We can simplify that, right? So this turns into x to the 1/2, y to the what? 6. Good. That's it. That's all we're doing with those. We're just rewriting it. Okay? Pretty good, right? All right, let's look at the next part. It says rewrite the expression using radical notation. Okay, so now we're going from an exponent to the radical form. So if I have 9 to the 1/3, remember this is power over root. If you need to, write that down before you start doing this. So I'm going to draw my radical. I'm going to put my 9 inside there. What's the power on the 9? 1. Do I have to write the 1? No. What's the root for this guy? 3. So you got to put a little 3. Your index. Now, please make sure that you tuck the little 3 in the, the radical there. Don't make it look like this. Okay? Because then this turns into 3 times the square root of 9, which is 3 times 3, and that's 9, right? We don't want that. We want the little 3, okay? Now let's look at the next one. Draw my radical. What goes inside the radical? Yeah, negative 243. What's the power on this guy? 1. What's the root? 5. Alright, there you go. So you don't have to write the power of 1, right? Let's look at the next one. X. What's the root? What number goes in here, this little 4? And then, what's the power? Yeah. Okay. Alright, so you guys try the next one, please. Okay, so you should have 12. Let's see, it's a square root and power 3. Yeah? Okay, so the next one. So we have x's, we have one x and we have a y. I was gonna say x's and y's, but it's just one, right? One x, one y. Do they have the same root, guys? No. The x has a root of 3. The y has a root of 4. So, I'm just going to draw 2 different radicals and then they just multiply. Okay? So for the x, power 2 cube root, right? Times, well, the y has a power of 1, but what kind of root? Yeah, it's a 4th root. All right, so there you go. Okay? Any questions about this? Okay. So the next part is going to be just simplifying radicals, which we've done, so that's good. This is an evaluate the following expressions. All right, so I'm going to show you the long way, and then we're going to talk about a shorter way. Okay? So if I have the cube root of 125. All right, so before, when we did square roots, we needed 2 in a group for it to come out. Do you agree? Now you guys are going to have different numbers as your root. Well, that root number is what tells you how many you need in the group in order for it to come out. Okay? So now, instead of 2 in the group to come out, now we have to have 3 in the group to come out. Okay? So let's do that. Let's break down 125. Guys, if I break down 125, what is it? What times what? 5 times what? Guys, do 125 divided by 5. Since it ends with a 5, it's divisible by 5.
25 times 5.
Yeah. It's 5 times 25. Remember, we're trying to get the prime numbers. We're trying to break it down into prime numbers. So, cube root of, okay, let's see, this 5 can come down. And then this 25 is 5 times 5. I'm done breaking it down into prime numbers. Do I have 3 of the same in the group? I mean, like 3 of the same thing? Yeah, right? I have 3 5s. That means that one of them can come out. Do I have any left over that need to stay inside? No. So this is it. Cube root of 125 equals 5. Okay. You know, whenever you see numbers inside these roots, the first thing I would do is just put it into the calculator. If you get a nice pretty number, then you're done. If you get a decimal, then that means we're probably going to have to use the long way and break it down, okay? Unless it says round to the nearest whatever and give me the decimal, all right? So let's see. Let's just, just to review. Cube root, math, 4, 125, and I get 5, okay? Let's try the next one. 4th root of 144. Let's see if we get a nice pretty number when we put that in. You guys know how to put in the 4th root?
You go down.
Math, and you go to number 5.
Okay, so if you go into math, number 5 would be the only option, right? Because it has an x in front of that radical. So you can make it whatever root number you need it to be. You have to make sure you put your root number first. So we're going to put 4, and then we're going to go to math, and then we're going to go down to 5. Okay? Because then now I told the calculator, okay, I want the 4th root. Does that make sense? And then 144. Oh, nope, I got a decimal. I have to do it the long way. Okay? So 4th root of 144 means I need 4 of the same in a group in order for it to come out. Yes? So let's break this down. 144 is what times what?
12 times 12.
12 times 12, okay? I can break down each of those 12s, right? So this 12,
6 and 2.
okay, and then this 12,
6 and 2. You have 4, but they're not the same.
and 6 is not a prime number, so you could break down those 6s, right? So this 2 can come down.
2 and 3.
So that 6 can be 2 and 3.
And 2 and 3 and
This 6 can be 2 and 3. And then you have that 2. Do you agree?
we have 4 2's, but you only have 2 and 3.
Okay, that's fine. You only want to look for 4 of the same thing, right? So Tom's right. We have 4 2's. We have 1, 2, 3, 4. Do you agree? Do we all see this? Okay. So then that means that 2 can come out. But, you know, these 2 3s here, they can't come out. We don't have enough. So they have to stay in, and we just multiply them. What's 3 times 3? 9. So this is my final answer for that. 2 times the 4th root of 9. Okay? This is a review, right? We've done this, simplifying these radicals. Now we're just looking for different number roots. Okay? Now let's look at the next one. 32 to the 1/5 power. You know, this is the same as saying, if we were to rewrite this, 32, what's the power? 1, what's the root? 5. This is the same as writing that, yeah? You know, whenever you see these rational exponents, you can also put it into the calculator and just see if it gives you a nice, pretty number. Into the calculator, you would put 32 to the, and then your exponent is a fraction. And remember, whenever you put fractions into your calculator, you need to put parentheses. Do you get a nice, pretty number when you put this in? 32 to the 1/5 power. Kevin says yes. Tom says 2.
Yeah.
Yeah? What is it? 2. Okay? Because the 5th root of 32 is 2. Abner, did you try it? Yeah? Did you get 2? All right. Ethan, did you try this? Did you get 2? All right. Sabrina? You doing it now? You didn't get 2? Okay, you know what? Show Kevin or Abner what you put in the calculator. So I like when they give me, you know, I can just try putting these into the calculator, right? Because we've talked about how to rewrite them. So this one, all right, let's put it into the calculator and see if we get a nice, pretty number. Make sure you put it in this way, parentheses, negative 125 to the, parentheses, 2 divided by 3. Tell me what you get. You get 25? You are way ahead. Thank you. You should get 25. If you do not get 25, please let me know. But everyone should try this. Make sure you get this, okay? Next one's a little bit trickier. All right, let's try the next one. You know, this next one is a little bit weird. So I want to make sure that I put this in exactly the way I see it. So the negative is on the outside of the parentheses, right? So I'm going to put negative, and I'm going to put parentheses. Yeah? 256. Oops. Nope, not 2 of them. Let me delete 1. There we go. Right? 256 to the, what's the power? To the 1/4. So I still need to open parentheses again and put to the 1/4. Right? So, okay, so if yours is fancy and then it's already up in the exponent, hit the right arrow so it comes down. If not, look at this. I have an open, I have 2 open parentheses, right? So you need to balance it out. You gotta have close and 1 more close. Does that make sense? If you open twice, you gotta close twice.
-4.
Yeah, -4. Does this make sense? So these are nice because we didn't have to do the long way because the calculator gave us nice, pretty, non-decimal numbers. So let's try the last one. Tell me what you guys get. 81 to the 3/4 power. 27. Oh, I should have recorded that. That was like in unison too. Try for another for that one. Remember, unless it says round your answers to the nearest whatever, like this one, okay? I don't want decimals, all right? If your calculator gives you a decimal, you have to do the long way, all right? But these are the exceptions. Like I said, sometimes it says round your answers. That's fine. We just have to put it into the calculator. So this one is the 7th root of negative 4,573. I showed you guys how to make this a 7th root on your calculator, right? So let's try it. We got to put that 7 first, right? Our root number. And then we're going to go to math. And then we're going to go to number 5. Negative. Yeah? So look at that. That's what you should have, yes? Okay, so we have to round it to the nearest hundredth. That's 2 decimal places because 100 has 2 zeros, right? So negative 3.33. Okay, let's do the next one. Well, the next one is written as a rational exponent. So I like those. They're easier to put into the calculator. $257 to the 5/3. Yes? You get a really big number. You have 10,388.56. Yours goes up because yours is nicer. That's why. Yeah.
Will you take points off if you round?
If you don't round it correctly, yeah. Yeah, you guys know how to round, right? Okay. Questions so far? All right, so here's the fun stuff. This is what I wanted to get to. So we have some problems, right? Some radicals with numbers and variables, all right? So we're going to try these. So now the first one, this is a cube root, guys. So how many do I need in the group in order for it to come out? Huh? Wait, what happened? If I have a cube root, if my root number is a 3, how many do I need in a group in order for it to come out? 3. Thank you. All right. So just take it one step at a time. And, you know, if you have numbers and variables, just start with a number, okay? So the first thing I would do is put in the cube root of 81 to get a nice, pretty number. Somebody put in your calculator, please. Cube root 81. You get a nice, pretty number. No? All right, then we have to do it the long way. Cube root of, how do you break down 81? What times what? What times what? 9 times 9. Good. Yeah? And those 9s you can break down further. Each 9 is what times what? 3 times 3. Thank you. Three is a prime number, so I'm done here. Now I need to take 3. That's my group, right? And then one of those comes out. So over here on the right, I'm going to just draw a little answer box so that I can keep my work organized. So one of those 3s came out. Since I still have A's and B's that I need to simplify, I'm going to leave some room, and then I'm going to put cube root, and I'm going to put whatever is left over that needs to go inside the radical. I'm going to put them in there. Does that make sense? Okay, so this lonely 3 here, that one needs to go back in. Didn't have enough to come out. Any questions on this? All right, so we're done with the number. Now I'm gonna look at my A's. So inside, guys, how many A's do I have? What is it? A to the what power? 6. Well, that means I have 6 A's. 1, 2, 3, 4, 5, 6. Okay? How many do I need in a group to come out? 3. So here's a group of 3, and here's a group of 3. How many groups do I have? 2. So that means A squared, 2 groups come out. Okay? Or like 2, 1 from each group, right? Did I have any left over that need to stay inside the radical? Any left over here? No. So let's look at the B's. How many B's do I have? 9. That over. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see here, right? We have groups of 3s. How many? 3 groups of 3s, right? So that means 1, 2, and 3 come out. Do I have any left over that need to go inside the radical? No. So that's it. I'm done. That's my answer. Okay? Just don't forget your little root. Don't forget that index. If it is a cube root, you need to put that 3 there, or it becomes like a square root. Okay? And then you just change the problem for this one. All right? Okay, let's try the next one. So the next one, I have, look at that, guys. I have a 2 that's already on the outside. So that 2 just has to wait, okay, until you bring things out, and then it's just going to multiply with any other numbers that you bring out. Does that make sense? All right, so let's see. Inside, I have x to the what? What is that, 8? Yeah? Okay. So this is a 4th root, so I need groups of 4, right? Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8. Group of 4, here, and here. Yeah? So that means, okay, I'm going to bring this 2 over because that 2 is just on the outside. Yeah? How many x's come out? 2. X squared. And by the way, this 2 just came from that 2 that we already had. Okay? Now look at your y's. How many y's do you have? 12. How many do you need in a group? 4. Do you guys see what I'm doing here? You're taking that number and you're making groups of 4, but you're just dividing. Yeah. What is 12 divided by 4? Oh, 3. Okay? So really, it's like you're saying y to the 12 over 4, right? Isn't that power over root? Y to the 12 over 4? Yeah? And 12 over 4 is 3. So there you go. Okay? You could draw it out. That's fine. All right? But with this one, 12 over 4 is exactly 3, so you're good. You know you don't have any left over. Okay? Power over root. Yeah? And actually, you had nothing left over to go back inside the radical, so you don't have to put a 4th root again. That's just your answer. 2x squared y cubed. Okay? Questions so far? No? Okay. All right, let's look at that last one there. 3x times the cube root of 512, x to the 7th, y cubed. Okay, so guys, this 3x is just going to wait. So in my answer box, I'm going to put 3x because it's already outside. Okay? Now, I'm going to do just the number first. Can somebody put in the calculator cube root of 512? Tell me if you get a nice pretty number. Huh? You get 8? Anyone else get 8? 8? Okay, perfect. Then that means 8 comes out. Now, why is this not? Alright, delete that. Okay, now let's look at the x's. Guys, how many x's do I have? 7. How many do I need in the group? Okay, if I do 7 divided by 3, do I get a nice even? No. So you could still divide and think about the remainder, or you could draw this out. All right, it's only 7. 1, 2, 3, 4, 5, 6, 7. Groups of 3. So here's 1, and here's the other one. So how many x's come out? Huh? 2. There's 1, and here's 2, right? The circle ones come out. So x squared comes out. What stays in? The x. Okay. Cube root x. Alright. I guess I should have put those in my answer box, but I'll do that in a second. Actually, we can do that now then. Let's bring those over. Answer box. Make some room. Cube root. Put an x there. Yeah? Sorry. Alright. Now let's look at the y's. How many y's do I have? 3. How many do I need in the group? 3. So the y's, isn't that power over root? Right? What's 3 over 3? 1. Which is just y. Or you could do 1, 2, 3. How many groups? How many in the group? 1. Sabrina, does that make sense? Am I going too fast? Okay. So 1y over here. Okay? Now, my answer box is really cluttered right now, right? I don't need 2 x's, and I don't need 2 numbers. They should be multiplied. I should just have 1 of each. So, take just the numbers and let's multiply them. What's 3 times 8? 24. And let's count how many x's we have. X, and we have 2 x's. How many do we have total? 1, 2, 3. Okay? When you have the same bases with exponents and they're multiplied, you add the exponents. Okay? And then we have just the 1y, and then we have cube root of x. So this is your answer right here. Okay? Any questions? All right. Let's try the next one. All right, so the 7th root of negative 128 x to the 7th times y, right? So put that in your calculator. Try it. Put in the 7th root of negative 128 and tell me if you get a nice pretty number. get 2? Anyone else get 2? Did you get 2 or negative 2? You should have negative 2. Did you put in 7th root of negative 128? Okay, it's a negative. Got to make sure if you have an odd root with a negative number inside, we use that sign. Okay? So this should be negative 2. Alright, so negative 2 just comes out. This is nice. We don't have to do the long way with these. And then let's look at the x's, guys. How many x's do I have inside? 7? 1, 2, 3, 4, 5, 6, 7. How many do I need in a group to come out? 7. So all this is one group, okay? So 1x comes out. Now let's look at the y's. How many y's do I have inside? Just 1. Wait a minute, but how many do I need in a group to come out? 7. Can I take this out? No, I don't have enough. So 7th root, and then just put the y back in. There you go. That's your answer. Okay? I feel like you guys are doing pretty good with this. I mean, a lot of you are nodding your heads. You know, Abner and Tom are participating, shouting out answers. Tim, when I see you, the eye contact, good. All right, good. All right, let's look at the next one. I think we have time for this one. Yeah, we do. So put in the 4th root of 256 and tell me if you get a nice, pretty number. 4? 4. Good. So 4 comes out. Now let's do our variables, guys. X to the 21st power. So I could draw out 21 x's. I really could, but I don't want to. Okay. So here's what I'm gonna do. I'm gonna show you another way. You can. Okay. So I'm gonna show you another way. X to the 21 over 4, right? So basically what you're doing is you're doing 21 divided by 4. Regular long division. What is the closest number you can get to the multiple of 4 without going over 21? 20, right? 4 times what gives you 20? Oh, and here.